Hello, my friends and quantum enthusiasts, and welcome to another episode here of the Hidden Quantum Champions at the Polaris School of Quantum YouTube channel. Today we are looking at the Quantum Internet Alliance, and without further ado, let's hop right into it and learn more about what they're actually doing. So here we are on the website of the Quantum Internet Alliance, and it says Quantum Internet Hackathon 2025 now open for registration. Sign up here. We're not going to do that. We want to check out what this alliance is actually about. It says building a global quantum internet made in Europe, and then here in the background we see a European map with different centers here that are connected into some type of web. It says QIA, so Quantum Internet Alliance, is building the world's first full stack quantum internet prototype network and steering the European quantum internet ecosystem to new heights. Learn more about our world's first prototype quantum internet network, and then discover how we are becoming a European platform for quantum internet innovation. QIA in a nutshell: we are pushing the frontier of technology in both end nodes, trapped ion qubits, diamond NV qubits, neutral atom qubits, and quantum repeaters, rare earth-based memories, atomic gases, quantum dots, and is set to demonstrate the first integration of both subsystems. Our world-leading and multidisciplinary team of academic, industrial, and research technology organizations puts us in a strong position to make this a reality by 2030, so in 5 years from now. Then down here we see some news. So I'm recording this in round about mid of November, and we see here 10 to 12 November. So that's, I think, pretty much up to date. And down here we see our products and platforms. Explore the products and platforms that are part of QII activities. And I mean, as previously mentioned also in the text, right, this is a consortium. So you have on the one side academic players, but then also industry players that are forming this alliance, that are working together. And here I guess you see some of the technology that goes inside, so different components and probably also different software parts. Then here about read our members' experience are some references down here, and some way to work with them and opportunities. At the end it says it's funded by the European Union's Horizon 2020, and you see here the Quantum Flagship logo as well. Now, with that, let's quickly jump over to their work. So our prototype network, just as an example, our prototype network, we are building the world's first quantum internet prototype following a systems engineering approach. We are building a full stack prototype network that can distribute quantum entanglement between two metropolitan scale networks and over long distance using quantum repeaters. The system will be based on state-of-the-art quantum hardware and software we developed in the past. The prototype network will include photonic clients, devices that allow future users to run higher stage quantum network applications between distant processing nodes of the network. All elements of the network, including our processing nodes and repeaters, are designed to be compact and portable to allow for operation outside the lab. Parallel to the focus effort to build a prototype system, we are also exploring alternative hardware platforms and other technical solutions that have a clear potential to improve the performance, scalability, and functionality of the final product. So this is a good opportunity to take a sip of water. Always stay hydrated. So this is a network that is using the properties of quantum to transfer information. So for example, for encryption protocols like quantum key distribution, but then on the other hand, also to connect two distant, let's say, quantum compute units, for example, and build this way a network that can distribute quantum entanglement also between different computers so that you can hook them up to become one bigger compute unit. Now, I think there's a couple of interesting things to that. One thing that is also to be pointed out here are the quantum repeaters. quick word on those. So they are very crucial because, as we've seen also in earlier episodes, we are trying to make use of the existing telecommunication fiber network, and that means that every once in a while also a photon is getting lost, and here a photon is basically referring to the full information package. So basically you need to make sure that at some distance you are kind of taking this information again and then repeating it, so that it kind of gets amplified, or not amplified, repeated again, because it's a quantum information. Now there's this idea of the non-cloning theorem, so you cannot just copy the data, and that is what makes it kind of difficult, because now suddenly the challenge is not only, and that's why it's also a repeater, is not only to extend by copying information, but really to take the quantum information and repeat that. And that's a whole challenging task in itself. Then here the key components for our quantum network. So it says Metropolitan network is one part. So we aim to build Metropolitan networks that can distribute quantum entanglement as a network resource to enable running complex quantum network application, to ensure functionality, scalability, and integration between networks across long distance. We are developing the following building blocks, and then you can read more here for information about that. Then there's the long distance backbone. We are enabling quantum repeaters based on heralded entanglement of efficiently distributed entanglement and entangle long-lived qubits in a quantum internet. To achieve this goal, quantum memories with high performance in terms of memory efficiency, storage time, and multiplexing are needed. And then finally, there's also the software network stack, because this is to be operated as a telecommunication network in a way. You also need to have the whole networking stack that is, of course, developed for, let's say, digital classical information and technology, but not for the quantum information. So we are creating a quantum networked system that can run user applications on platform independent software. To achieve this goal, we are developing two stacks, the quantum node and control plane stacks. We already developed the quantum network protocol stack and demonstrated entanglement delivery through software and network stack. Now we are improving the stack for large-scale Metropolitan networks, which are connected over long distance. And then, you can see here the work teams for that. And I mean, there's also other stuff here. So this is the prototype network. There's the European Innovation Platform, work teams, QIA Technology Forum, and the Quantum Internet use cases. Let's quickly also check out the use cases. So they are listed here. Exploring real-world applications of quantum networks that enhance privacy, security, and efficiency across different domains. The quantum internet promises to revolutionize the way we communicate, compute, and secure information. By harnessing the principles of quantum mechanics, it enables applications that go beyond the capabilities of classical networks, offering unparalleled security, precision, and computational power. Below, we present some examples for use cases that illustrate how quantum network technologies can impact fields ranging from secure voting and whistleblowing to enhanced astronomical measurements and network optimization. Each use case example provides a sneak peek into how general-purpose quantum internet will shape the future, with links to deep insights for further exploration. So then we start with the Doctolib's document deletion. So quantum certified deletion. Quantum certified deletion ensures the confidential medical documents shared on platforms like Doctolib and can be permanently erased with mathematical proof, helping comply with GDPR's right to be forgotten. GDPR's the general, General Data Protection Rules. Not sure. I just know how it's called in German, but that doesn't really help here. HOM-based clock synchronization, so leveraging the Hong-O-Mandel effect. Quantum clock synchronization ensures ultra-precise timing across quantum networks, surpassing traditional GPS and NTP methods for secure communication, computing, and navigation. And a quick note on that, so we featured in an earlier episode of the Quantum Hidden Champions another company that is active in this field and working on these specific clock systems. If you haven't seen that, make sure to check out the Hidden Quantum Champions playlist on our YouTube channel. Then there's the secure position verification, so quantum secure multi-party computation, QSMPC, enables users to prove they are inside or outside a designated area without revealing their exact location, ensuring privacy in sensitive scenarios. Then the quantum enhanced SDN management, control and orchestration by integrating quantum network technologies into software-defined networking. SDN networks can achieve more secure, scalable and efficient management, including improved leader election for critical decision making. Then the one-time proxy voting. Quantum one-time programs enable secure proxy voting by ensuring that a delegated vote can only be signed once, preventing fraud and enhancing trust in elections and decision making. So you see these two ones, this really goes into, both of them, they really go into the election process, so voting, electing. Then the multi-party entanglement for secure distributed function estimation, so leveraging entangled quantum states. This approach enables secure and precise distributed calculations such as clock synchronization or sensor data aggregation without revealing individual user data, so anonymization in a way. Very long baseline optical interferometry. Quantum networks enable astronomers to overcome distance limitations in optical interferometry by using entanglement to measure stellar phase information across widely separated telescope, enhancing resolution without direct photon transmission. So this is, let's say, a scientific application, so that it can enhance science, in that specific case astronomy. So if you, for example, think about a telescope, there's the one that you can put on your balcony or into your garden, which might look like, or maybe think about the handheld version, right? You can use that to see something that is far away from you. But actually, the size of the telescope itself is kind of correlated to how far you can look with it. So if you, for example, look at how telescopes look like in old university laboratories, you might see that you have these rounded dome-shaped type of buildings, and you can open the dome and then you have the telescope inside. And then if you look at, for example, radio telescopes, you have these super huge dishes that are still somewhere around that are also for different wavelength, but they are even bigger, and there are even bigger ones that are not even dishes anymore. They're just antennas that are spread across a certain field, a certain area. And these telescopes, they of course have a certain limitation in how big they can get, because it's basically the size of real estate that you acquire or that you are using for these. Now, if you had this quantum internet, you could actually spread information within this network. So you could just have in different cities or close to different cities measurement stations, and then you could connect them coherently within this network. And I guess that helps you to actually create an even bigger telescope here on Earth for a specific photon type or frequency. Then there's the small-scale referendum. Quantum voting protocols offer a secure and verifiable way to conduct small-scale referendums, ensuring privacy and integrity under controlled assumption about trust and hardware reliability. Quantum whistleblowing. Quantum networks enable truly anonymously whistleblowing, allowing individuals to expose misconduct without fear of retaliation by ensuring the identity remains untraceable. And then finally, the quantum enhanced load balancing. By using shared quantum entanglement, distributed computing systems can optimize job allocation across multiple nodes, improving efficiency, even when direct communication between entry points is limited or costly. And these are, let's say, the applications that are pointed out here by the Quantum Internet Alliance. Some of them are, let's say, towards the scientific range. Other ones are more, let's say, on the security side. And then you see these democracy related or voting related things. They don't necessarily have to be, let's say, voting as in people voting for something, but also machines that are voting within each other for some types of algorithms, right? And this enables, of course, completely new use cases then. Quick look also on the resources, on the products and platforms that are actually being employed here. So we facilitate transition to market of quantum internet products. Building the full stack prototype network requires the development of innovative European components and subsystems, both in hardware and software domains. Many of these technological products are already recognized to have the potential to lead to innovative European products on their own from the very start of this partnership. And here we see some of the products, for example, the Q-blocks systems here, which are used for the cluster. Then there's Swabian instruments, Time Tagger X, the WeLink Q drive, I guess, for the memory. Then you have the MDI QKD Falcon series for quantum key distribution and the modular clock laser system from Toptica. Some of these companies we have already featured. Again, if you haven't seen the video yet, check out the playlist. Then it says we lay the foundation for a world-leading quantum internet software and service industry. Many applications are already known that showcase the potential of a quantum internet to radically enhance internet technology benefiting several key sectors of society. With our suite of platforms available to the public, scientists and engineers now have access to tools that will help them design future quantum internet as well as modular quantum computing architectures. Check the platforms below and try them yourselves. And here are, let's say, the different software platforms that are part of this quantum internet alliance. So there's the Squidasm. Squidasm is an advanced quantum application SDK software development kit developed by QTech that can be used to execute applications on a simulated quantum network. It is offered as part of QTech's Quantum Network Explorer and is QIA's dedicated quantum application simulator. Then there's NetSquid. NetSquid is a powerful low-level simulator for quantum networks that follows the paradigm of discrete events. This software can be used to model networks with thousands of end nodes and qubits as well as repeaters. So both of them, they are in the, let's say, simulation part of the software stack. Then the Quantum Network Explorer, that one was mentioned before, right? The Quantum Network Explorer, QNE, is an online platform where users can learn about quantum networks, explore various applications, and write their own applications using QNE's application development kit. Currently, QNE is running on a simulated backend supported by NetSquid. In the near future, the platform will also allow access to real quantum hardware. So this is the Quantum Network Explorer, where you can play around with the quantum network, still running with a simulation backend right now, and then at some point, similar to the quantum computers, moving to the early stage hardware. Then there's the Quantum Protocol Zoo. The Quantum Protocol Zoo is an open repository of protocols for quantum networks. It provides a compact and canonical way to explore such protocols. Moreover, it allows for easy communication among computer scientists, engineers, and physicists on a single platform. And I think that's very similar also to the quantum computing, the Quantum Algorithm Zoo, which is a list of all the publications and all the algorithm ideas that people are putting out there for quantum computers. And this is now something that I think is in a way similar for quantum networks. And then finally you see the simulacron. A simulacron is a tool for software development over a quantum internet. Specifically, simulacron provides a distributed simulation of several quantum processors connected by a simulated quantum communication channels. So this is basically, let's say, using, I guess, quantum computers, it's basically the quantum internet software tool. So the software suite, once you have quantum computers in the quantum connected to the quantum internet, then this would, I guess, be the preferred layer, application layer to actually use with this, or the native language for this new type of internet. And then again, here you see there's initiatives, news, events, scientific publications, and public deliverables to check out. Finally, as always, let's quickly also check out the About Us tab, so the QIA story. We are a community of world-leading and multidisciplinary institutions and industry actors in Europe. With the Alliance's history of record-breaking demonstrations and breakthrough innovations, we are poised to achieve our moonshot mission of building the world's first global quantum internet made in Europe. In parallel, we are mobilizing the industry to create an ecosystem ready for quantum internet development. In 2017, I think that's probably the first timestamp that we have here, QTech, ICFO, University of Innsbruck, and the Paris Center for Quantum Computing joined forces to strengthen the European efforts in quantum internet development. The parties signed the letter of intent and memorandum of understanding signifying commitment to build a large-scale quantum internet that ultimately allows quantum communication between any 2 points on Earth. Then in 2018, you see the quantum flagship here. We were selected as part of the European quantum flagship ramp-up phase 2018 to 2022. Here you see the quantum flagship. We are part of the EU Quantum Technologies Flagship, a 10-year initiative launched in 2018 by the European Commission with an initial budget of €1 billion. The quantum flagship aims at enabling Europe to stay ahead in the second quantum revolution about quantum sensing, communication, and computing. That's where the idea basically comes from, or these three categories, I think. Kickstarting a competitive European quantum industry and making Europe a dynamic and attractive region for innovation, research, and business investments. Quantum Internet is one of the areas recently identified by the European Commission as highly strategic. You can learn more about the quantum flagship here. Its research and industry strategic agenda to which we contribute can be found here. And then 2022 as the last timestamp in the series here, we signed a multi-annual partnership agreement with the European Commission to build a quantum internet made in Europe 2022 to 2029. So in 4 years, or probably less than 4 years, we will see some results here, hopefully. The European mission has selected quantum internet as a strategic area for investment to build a global quantum internet made in Europe. As such, QIA started a 7-year program with the aim to develop a full-stack prototype network connecting distant cities. For more information, check out here. And I guess here is some references to learn a little bit more, to read a little bit more into that, and then again call to start working there. Let's quickly also check out who is part of this alliance. So we see it's spread across Europe, mainly I think the western part of Europe, not so much in the eastern side. And we see it's a mix of universities and research labs and also players from the private sector. So for example, we see Alpine Quantum Technology, which is of course also a part of the Hidden Quantum Champions series. We see research institutions like CEA, universities like the University in Dresden, but of course also TU Delft, as I think one of the hotspots for quantum technology with the QTech here in Europe. There are also research institutions like the Fraunhofer and the Max Planck, which are very important players also in Germany in the research part of in the research ecosystem. You see Q-Blocks, which are of course also supporting with their products, and many, many more. You see RWTH Aachen University, which is my alma mater, the SAP as a company, of course, as a big tech company here in Europe, and many, many more. You see Thales, for example, here, Telefonica, and others. So I think that's pretty much a quite powerful consortium that you have here. On top of that, there's also an advisory board with some people from various different backgrounds. You see University of Oxford, but you also see IQM, you see Deutsche Telekom, Zeiss, so various different backgrounds. You see both academia and industry, but I think it's more like industry heavy here. RIPE, NCC, I don't actually know. And then, okay, there's also more here regarding the countries that are being represented. So there you see it's actually throughout Europe, different countries that are being represented in here. So it's actually, let's say, a pretty broad alliance across Europe. It's a European initiative to work on the quantum internet. And I think I've mentioned that before, like first tests are ongoing. People are experimenting with this different quantum key distribution hardware, quantum key generators, repeaters are very active research. There's memories that we've seen, for example, here. And I guess the Quantum Internet Alliance is where all of this comes together collectively and is then being developed into something bigger, which is a quantum network. If you find this video interesting, don't forget to like it. If you don't want to miss out on the next one, which potentially could also be again on the quantum internet, then make sure to subscribe to this channel. And I hope to see you again soon. As always, make sure to stay hydrated and see you in the next one. Bye bye.